All right, so the next session is the multiplication rule of probability. And the multiplication rule enables us to calculate the probability that two or more events will occur concurrently or at the same time, okay? We often refer to the multiplication rule as the joint probability, okay? So one way for the multiplication rule to be effective assumes that the events are independent, okay? So if the event A and B are independent, then the multiplication theorem states that the probability of A intersection B is equal to the probability of A multiplied by the probability of B, okay? So the probability that A and B will occur is basically equal to the product of the imaginary probabilities. That's what we have here. All right, similarly, for a finite collection of events A1, A2 up to AN, the multiplication theorem states that the probability that this event occur concurrently is equal to the probability of um, the product of the imaginary probabilities, okay? So the probability that A1, A2 up to AN will occur at the same time can be expressed as the product of the imaginary probabilities, okay? That's what we have as defined in equation 6. Now we can generalize equation 6, right? Once we generalize equation 6, we have it as defined in equation 7. So equation 7 is the generalization of what we have in equation 6, okay? All right, so now let's take an example. A small town has one fire engine and one ambulance available for emergencies. The probability that a fire engine is available when it's needed is equal to 0.88 or 88%. And the probability that the ambulance is available when it's called is 0.91 or 91%. So in the event of an injury resulting from a burning building, I want to find the probability that both the ambulance and the fire engine will be available, okay? So let's look at the solution. Let A and B denote the respective event that fire engine and ambulance are available. And these two events are independent, okay? Because you can see that the operation of fire engine is different from that of the operation of ambulance, even though they have the same goal of trying to quench fire when there's a fire outbreak, but these are two different operations altogether, okay? So the probability that both services will be needed when there's a fire outbreak can be defined this comes probability of A and B. Because they are independent, you can express it as the product of the imaginary probabilities. We have probability of A multiplied by probability of B. And the probability of A is equal to 0.88 multiplied by that probability of B, 0.91. So once you multiply this, you obtain 0.8008, okay? All right, so this is the solution for example 3. So this is a trial question. I'm going to link the solution in the description of this video so you can check it out. Don't forget to subscribe if you have not, and also thank you for watching.